Welcome to Chapter 3. A physical property can be measured or observed, and it doesn't change the chemical structure. Sometimes we say it doesn't change the composition. But a chemical property is observed during or after a chemical reaction. In this case, the chemical structure does change. For example, gas has a distinctive odor. That's a physical property, and it doesn't change, but the flammability is a chemical property. It changes its composition when it burns. Here's some examples. We start off with mercury 2 oxide. That has physical properties of red, colorless, and it's almost insoluble. It also has some chemical properties. It's going to decompose when exposed to light or energy. And when it does that, it's going to change its composition because it's going to change then into mercury and oxygen. And they both have their own physical and chemical properties. Oxygen physical properties, oxygen chemical properties. Mercury physical properties, mercury chemical properties. State changes are going from one state of matter to another. For example, solid to liquid. They're also called phase changes, and these are always physical changes because no part of the composition changes. For example, if I have liquid water, I have H2O. When I separate those molecules and make a vapor, they become a gas, then they are still H2O. The gas is still water. If we're talking about physical changes, just like the changes of state, the matter changes its appearance but not composition. Again, we're talking about water. If it melts, it still is H2O. If it turns to steam, it's still H2O. If you take a piece of paper and tear it up, it looks different, but its composition is still the same. If I take wax and melt it, it is still wax. It still has the same chemical formula. In a chemical change, the matter does change its composition. You have a new substance. Please, when we talk about chemical change or chemical reactions, please don't say that it can't go back because in some cases it can. If I have my water molecule and I add electricity to it or energy, I can separate the water into hydrogen gas and oxygen gas. That is a chemical change. We have new substances. However, I can take oxygen gas and hydrogen gas and change it back to water, and that releases a lot of energy. Another example is copper exposed to air turns green because it makes copper oxide a new substance. When matter undergoes a chemical change, it's a reaction. Before the chemical reaction starts, we have reactants, and whatever is present afterwards is called products. We use this arrow to show that we've gone from reactants to products. Some signs of a chemical change are heat either being absorbed or released, light being produced, gas being produced, often we call this bubbling if it's in a liquid, or a precipitate, a solid that's formed by mixing two liquids together. If we compare chemical properties versus chemical changes, chemical property is the fact that iron will rust. The act of rusting itself is chemical change because we go from iron atoms to iron oxide. What are some signs of this chemical change? Although it happens very slowly, rust releases energy. If you've ever used a hand warmer, or if you've injured yourself and you've used something called Thermacare, those packs that you put on your body, those are typically iron rusting, but they have a catalyst so it happens faster and the energy is released. Vaporization, as we talked about, is a physical change. If I take a lighter, it has liquid butane. If I push the button without turning the flint, without making a spark, gaseous butane is released. So it's gone from a liquid to a gas. That's a physical change. But if I push that button and that turns a flint and I create a spark, then I have a flame. So light is being produced and energy is being given off. This time the gaseous butane is changed to carbon dioxide and water. That's a chemical change. Pause the video and decide if these are physical or chemical changes. The melting point is physical change, chemical change, flammable. Density is physical, shape is physical, solubility is actually physical, and tarnishes. So if I have silver and it tarnishes, that is actually a chemical change because the silver has been changed to silver oxide. That's what tarnish is, some sort of oxide. And many metals tarnish or change into their oxide. Looking at some changes, physical versus chemical. We talked about rusting. We know that is chemical. Dissolving in water is a physical change. When something is dissolved in water, I can evaporate the water and the substance is still there. It will become a solid again. Burning a log is chemical change, you produce carbon dioxide and water. Melting ice is a physical change. All state changes are physical. Grinding spices is a physical change. The spices are still the same chemical composition, they've just been made into smaller pieces. If you cut a pie into several pieces, does it have less mass? No. If I take a guitar and smash it into bits, does it have less mass? No. If I take that pie or guitar and put gas on it and ignite it and allow it to burn until all that was left is a pile of ashes, would the mass of the final products be less than the starting materials? No. In chemical changes, no matter what we do, mass is neither gained nor lost. This is the law of conservation of matter. So why does it look like there was less mass? Because some of the final product was a gas, and that can be difficult to measure or see. A precipitate is a sign of chemical reaction. Yes. When you study energy in chemistry, it's called thermodynamics. The law of conservation of mass, just introduced, is also known as the first law of thermodynamics. There is not any new matter created in common chemistry. Matter is neither created or destroyed. During both physical and chemical changes, the total amount of matter remains constant. Looking at a chemical reaction, the total mass or the sum mass of the reactants is always equal to the sum mass of the products. Going back to the butane in a lighter, we have 58 grams that is burnt because burning is a reaction with 208 grams of oxygen. The total then of our reactants is 266 grams. The products are carbon dioxide and water. We have 160 grams of carbon dioxide and 90 grams of water. Totaling those up is 266 grams. Even though the products are gaseous, they still have mass. And notice that the total mass is equal. Pause the video and give this one a try. We have 5 grams of mercury 2 oxide, and we know it's going to produce mercury and oxygen. It produces 4.63 grams of mercury and some oxygen. How much oxygen is produced? The total of the reactants is 5 grams, and so that means the products has to equal 5 grams. Setting it up as a simple algebra problem, or simply subtracting the mercury from the mercury 2 oxide, the mass of the oxygen was 0.37 grams. Antoine Lavoisier was credited with discovering the law of conservation of mass. He was beheaded during the French Revolution. A year and a half later, too late for him, he was found innocent of these charges. 100 years after his death, a statue was finally erected in his honor, but it doesn't look like him because, again, with the head, they used a spare head to save money.